So Charlie O'Keefe is an engineer at Zcash Company, and he's going to talk about building Zcash on Windows.
Okay, I'm not really sure who my audience is here.
Everybody who wants to build Zcash for Windows.
This is a very developer-centric talk, and it's the kind of talk that I would love to give to myself from just a few months ago. And it's also for anybody who has like a very Unix-centric project and would like to port it to Windows and doesn't know much about Windows. So I came in not knowing much about Windows. I've mostly used Unix, used Windows back when like it was Microsoft's glory days, and haven't done a lot of development on it before. And so here we have this Unix project. And this talk is really about building and testing on Windows. The building part was largely solved by people before I came on board. This guy sitting right over here might know more about building Zcash on Windows than anybody else in the world. So I came in first wondering what compiler toolchain is the right one. And I asked this, and looking back at it today, I was embarrassed because Cygwin is not actually a compiler toolchain, but I had sort of heard of it as this, like, I knew it was out there as this way of running Unix software on Windows that was like not really native and slower and probably not really what I wanted, and I'll have more on that later. So it turned out MinGW, minimalist GNU for Windows, is something Bitcoin already can build on, and we already had a pull request aimed at supporting that, and that pull request is now purged. So today, the master branch should build on Windows. But
Now builds on Windows? Like with nothing, just...
Don't you mean cross-compiles from Linux to Windows?
yeah, I do mean cross-compile. So cross-compile here is running our main build command with a host environment variable set to target the Windows platform. So it just uses GCC's cross-compiling capability to target that platform. And we were sort of interested in doing that on some sort of tool in Windows that is aimed at supporting Linux software. And that's what a lot of this next bit is about. So Microsoft has this thing called Windows Subsystem for Linux. And I was sort of hearing that we were interested in, like, maybe this would be helpful. So the picture here basically shows on Windows, you can have like a native Windows process, which includes all these things on the left. And then there's a thing called a Pico process, which doesn't include those things. And it calls into a part of the Windows kernel that is there to support native Linux binaries. And it seems like cool technology. For the end user, it's essentially equivalent to having a Linux VM that is just better performant and doesn't occupy as much memory as a real virtual machine. But basically, you're getting native Linux that way. This is what it looks like for the end user. You select a distribution on the Microsoft Store, and you can run it in a terminal on the Windows desktop, and you can have multiple ones alongside one another. So here we have Fedora, OpenSUSE.
I love how Cali's like short.
Yeah, like Windows has a Kali builder?
Yeah, I don't know. I was mostly playing with Ubuntu.
That one only gets downloaded in China.
So there are rough edges for Windows Subsystem for Linux. Microsoft really intends that as a developer thing. So if I was initially thinking like, I don't know, maybe this is possibly a way to distribute software you've built for Linux and have Windows just run it, well, I think Microsoft says on their site that they had like web developers in mind who have like, you know, their Rails development environment they want, or whatever like set of Unix things that really don't port over to Windows very well. So that's their target audience. You have to specifically enable something, and it's not going to support graphical apps, or at least they don't recommend that. This is my favorite rough edge. This is a real page on Microsoft's site. They have bold, underlined, red text that tells you that you can't, like, you should not, under any circumstances, use a Windows application to open a Linux file. Like when you're using Windows Subsystem for Linux, you get a whole other file system separate from your Windows file system, and you can open files in one direction but not the other direction, and so you don't want to try to mix those environments too much because the Windows applications will corrupt the Linux file system. That's just my favorite rough edge. So since it's very much like a Linux environment, doing this Ubuntu subsystem on Windows did work for our build. We could run it the same way using the same cross-compile and build some executable binaries. So after running it, I have these binaries. And some of them are our test suite. So since I was interested in running tests, great, maybe I'm home free. So I try copying those binaries over from one subsystem file system to the other, and then just run them on the Windows PowerShell prompt. And it basically works. Like, it runs some tests. Some of the tests fail. I don't know if that's Windows specific or not, but you can run those tests. So again, progress. But we have this full test suite. This is a Python script in the Zcash project, and in that Python script is a list of these different stages of tests. And so the executables that I got that were related to test suites were actually those first two in that list. And so that was as far as I got using that approach. Those other ones have other reasons why this cross-compile isn't really going to get us there. In particular, some of those ones toward the bottom are actually running make commands, which means like you depend on like having the whole GNU toolchain basically like in your environment in order to run those test commands. So then I started returning to this idea of like, this is basically Unix kind of software, and we do want to run it on Windows, at least in the form it's in, as long as we have those tests. So this is the Cygwin picture. You have POSIX software, you have a translation layer, and then underneath the translation layer, you have the native Windows environment. But there's actually this family tree of Windows, Unix kind of interoperability tools that live in this world. And Cygwin is like the original one. And then there's this other one that was forked from Cygwin, but is much smaller and more purpose specific, called MSys. And the idea of MSys is there's some Unix software there, but it's aimed at building native Windows software. So you have tools in MSys. When you build something in MSys, you're not supposed to necessarily be building your app so that your app will use that POSIX translation layer. The idea is your build tools will use that translation layer. So maybe we can use that to help run the tests. But this picture is a little more complicated. There's also a thing called MSys2 that was also forked from Cygwin.
You want MSys too?
I learned that the hard way.
Almost 2 years ago, you put your head against the wall.
Yeah, MSys is is older. It was current further back in time, but it has not been kept up to date. MSys 2 seems like the word on the street is that it's kept more up to date.
I have a native MSys 2 builder if you want to get rid of all the cross compilation, but I haven't tried it on current recent Zcash.
We should talk. This is as far as I got with making slides before I got up here to talk. But okay, I'm out of time.
But if you want to wrap it up, go for it.
Okay, so yada yada yada, and most of the dependencies build, and that's it. Yeah.
Thank you, Charlie.
We had a question.
Do we have questions? Okay.
Yeah, so how far away are we from having an officially supported Zcash on Windows?
Right. So the purpose of all this was official support. So that to me means the CI system runs Windows builds when you check in code and runs the tests on Windows, just like it does that on Linux environments. And so most of that work now is in the CI system. So I've kind of shifted focus to making the CI system support that. And I know as soon as I figure out our infrastructure and how to update the CI system, not too long.